Hello friends, myself Madan Kumar Jha from Electrical Department IIT Patna under the course of VLSI and Embedded System. Here in Embedded System, our objective is to design a low pass filter on Stm32 Nucleo board where our cutoff frequency will be 23 Hz and our sampling frequency will be 256 Hz. So before implementing this low pass filter on STM32 Nucleo board, I am just going to tell you about what is the first order low pass filter. So this is basically the transfer function of first order low pass filter in frequency domain, where transfer function is equal to omega naught divided by s plus omega naught. Here this transfer function can be implemented in this Nucleo board, but this is in frequency domain. So for that I need to convert it into discrete time domain. So this transfer function can be converted into discrete time domain using this equation yn equals to alpha times x n plus 1 minus alpha times yn minus 1, where alpha can be evaluated using this formula 2 pi fc divided by fs plus 2 pi fc, where fc is our cutoff frequency and fs is our sampling frequency. So in our objective, our cutoff frequency is 23 Hz and our sampling frequency is 256 Hz. So from this we can evaluate the value of alpha is 0.3607 and 1 minus alpha is equal to 0.6392. From there our equation is obtained at this yn is equal to something something. Now this is our block diagram of low pass filter, first order low pass filter, where this is our input signal, this is our output, and this is our yn minus 1 state, that is previous state. Here now come to our objective. Here we need to first achieve the sampling frequency to 56 Hz. We need to generate a timer where that timer will exactly give the sampling frequency to 56 Hz. So for that we need to set the value of pre-scaler and auto reload register ARR for that timer. So here our objective is to set the timer sampling frequency is to 56 Hz. So the value of pre-scaler and ARR will be evaluated using this formula, where pre-scaler is equal to f system divided by ft into ARR plus 1 minus 1. So from there the value of pre-scaler is 4. Actually I am using here 65535 for ARR, where ARR is used to count 16-bit value. Now this is the Bode plot of our first order low pass filter. You can show here at omega c equals to 144.4, that is 23 Hz. The signals can be sampled down. So this low pass filter is basically here sampled down the signals after cutoff frequency. Okay. So after explaining all parameter of low pass filter, now I am going to show how to implement this on STM32401 Nucleo board. So you can see here in STM32401 Nucleo board there are several GPIO pins. This is our PF5 pins, where LED is basically connected in this board. Now GPIO PF5 pin is basically GPIO output pin, because LED is basically used to blink when the filter is active or inactive. And this is also our GPIO pin, where PC13 pin is basically connected with push-pull button, and this push-pull button is used to on or off the filtering process in our project. So we understand about GPIO pin. Now come to this ADC pin. So basically this ADC pin is used to convert the analog signals coming from the function generator to digital on this STM board. So here I am using this ADC 1 input 0 here. Now after configure this board, we need to set the timer at 256 Hz. So for that purpose I am going to select here timer 1, in this Nucleo board. So you can see here in this STM32 Nucleo board, I am going to select the internal clock source for this timer, where the frequency of internal clock source is basically 84 megahertz. So for converting that 84 megahertz into 256 hertz, we need to set the value of pre-scaler and auto reload register for this timer configuration. So I am basically set the value of pre-scaler as 4 here, and the counter period, that is auto reload register, 65,535. Basically this const 16-bit value. So after setting this all thing, we need to now generate the code. So here we can generate code by this button. Now after generating the code, we will reach to main section, but already I have generated that code, so I am now going to explain the code in front of you. So you can see here, this is our code for this low pass filter. So here basically I am defined sampling frequency 256 Hz and cutoff frequency 23 Hz for our project, and this is the prototype ADC handle type define, which is basically a structure to handle ADC1, and this is the structure for timer to handle TIM1. Now initially I set the value of alpha as 0 and previous state output as 0, and here I declare this ADC value as 0 and filter active is also 0 initially. So now come to the second part of this code. Here you can see the system clock is configure here, and MX GPO input and all those things, timers and ADC, all those are configured here. Now this is a basically function which is used to calculate the value of alpha, which so here I am defining a function which is calculate alpha, is used to determine the value of alpha for different value of cutoff frequency and sampling frequency. It can calculate different alpha, but in our case our sampling frequency is 256 Hz and cutoff frequency is 23 Hz, so it will calculate the value of alpha as 0.3607. Now after that, this is a function apply LPF, which is used to apply the low pass filter. Here you can see this is the function of this is the equation for low pass filter in discrete time domain, where output is something is defined in this manner. Now this is our previous output. After applying this low pass filter, this will store this output value in previous output. Now this wide error handler is basically used to error the any part in GPIO pins like LED or push pull button. So the main objective of the main part of our code is in this while loop. Before this, I am going to show you I am initializing here GPIO pin, ADC pin and timer pin, and here calculate the value of alpha. After calculating the value of alpha, I am going to store the value of ADC which is coming from function generator and timer value. Now in while loop you can show here the main code which is in this part of while loop. If HAL GPIO read pin GPIO A, GPIO pin equals to GPIO pin set. So when we push the buttons, it will basically set this pin, and after pushing that button, it will set a delay of 50 milliseconds. So why this debouncing delay is added here? Because after pressing any analog switch, some type of noise occurs. So avoiding that noise, I am declare here a delay of 50 milliseconds. After that, it again read this code and then set the, if again the push is continuously pressed, then it will set the filter active is equals to not filter active. That is, it is basically toggle the filter active status. That is, if initially our filter active is 0, so it will set it as 0 1, and if our filter active is 1, then it will set it at 0. So if filter active, then it will on the GPIO pin 5, that is our LED pin, and our LED will become glow when the filter is active. If the filter is not active, then our LED will be off. Here you can show this GPIO right pin basically give the command to turn on or off the LED. Now after that, this is the code for timer. Here this timer is basically set the frequency at 256 Hz, and the ADC value is basically stored, which is coming from the external signals from function generator. So this input signal is basically floating type, which is basically coming from ADC. So this value is basically stored in input signal, and the external source signals which is coming from function generator, that frequency is stored in input signal, and at that frequency the function apply LPF is applied. So this basically again on the filtering process of low pass filter. Now, so these are basically configuring of oscillator of this STM35, which is our inbuilt code. No code is written in here by me. This is auto generated by this software. Okay, so this was basically our code. Now you can see here, after writing this code, I am going to debug this code. So here I am going to build this project. So after building this project, you can see here our code has 0 error and 0 warning. So now this code is basically correct, and here in our code there is 0 error and 0 warning. Now I will show this on board and testing